Hello and welcome to Sean White's Solar and Energy Storage Podcast. The title of this podcast is Energy Storage Relevant Material in the 2020 NEC. That's NEC Chapter 6, Special Equipment, Chapter 7, Special Conditions, Chapter 8, Communication Systems, and Chapter 9, Tables, which is pretty much about the end of the NEC. So, in this podcast, we're going to cover Chapter 6 and 7 in the NEC, but not including in detail Article 706 Energy Storage Systems because we already covered that in a previous podcast, but we will still talk about it. And we're going to talk about all of this information from an energy storage point of view, which a lot of the times is very closely related to solar. We are going to include Article 625, Electric Vehicle Power Transfer Systems, and we call that EVSE, which is Electric Vehicle Supply Equipment. We're going to cover that. We're going to talk about Article 692, which is fuel cells, Article 702, standby systems, which includes the ATS, which is the automatic transfer switch, if you hear people saying ATS. Then we're going to cover MIDs, and that stands for Microgrid Interconnect Device. A lot of you are starting to see these microgrid interconnect devices when you're adding energy storage systems. And we're going to cover Article 705, which is very important for energy storage, solar, and all this renewable stuff. And that is interconnected power production sources. That includes supply side and load side connections. We're going to cover a little bit about Article 706 Energy Storage Systems, 710 Standalone Systems, Article 712 DC Microgrids, and Article 750 Energy Management Systems, also known as EMS. Then we're going to talk about PCS, which is Power Control Systems. And we are going to dive a little bit into Chapter 8, Communication Systems, because that's getting more and more important as we're networking all of our things together, talking on the internet. Then, last but not least, we're covering Chapter 9 tables. We're going to talk about the conduit fill tables and voltage drop tables. So now let's get deep into the material, and if you want to find out more about solar and storage, go to solarsean.com. On with the show. Here we are cruising through the National Electrical Code, and we're starting at Chapter 6. Chapter 6 is for special equipment, and so some things about energy storage systems are special, so let's talk about some types of special equipment in Chapter 6. And some of the things are probably not so relevant, especially office furnishings. You see, they got all kinds of things. Elevators. Hey, just interesting to note, though, is an elevator is a sort of gravity energy storage because as the elevator goes up, it takes energy, but when the elevator goes down, it actually feeds the grid. So to go think about it, an elevator might have been the first thing to feed the grid. Isn't that cool? So an elevator going down will feed the grid. So if you wanted to save some energy, what you could do is you could always walk upstairs and then take the elevator downstairs. And you would be taking that energy of you walking upstairs and sending that to the grid. They should pay you for that. Okay, now we're going to get to something that's relevant for what we're talking about, electric vehicle power transfer system. So this is something that they changed a little bit because usually we were talking about electric vehicles being charged, but now we're talking about transfer. That means that we can export power. By the way, too, if you wanted to get a little bit more advanced on this, I have some more advanced material. You could go to heatspring.com/Sean. You see my different classes and free class, solar building codes, fire codes, electric vehicles, rapid shutdown and energy storage systems, and with my friend Bill Brooks. And one of the topics that we go over is electric vehicle power transfer system and Article 706 energy storage systems, and an advanced discussion of different topics. So once again, you can find all of this information at heatspring.com/Sean, or easier, you can go to solarsean.com, and that will give you links to all different things that I'm doing, including HeatSpring classes, podcasts, discussion forums. But maybe you already know that because maybe that's how you got here. I even have flashcards, podcasts. Check it out. Talking about batteries. Good stuff. And back to the NEC, Article 625, Electric Vehicle Power Transfer System. So think of having an electric vehicle that can feed energy either to the grid or even to your house when the grid is down. But this also just covers your electric vehicle charger too. But since we're talking about energy storage, we're more interested in bidirectionalness. We're talking about bidirectional current flow. So that means it goes both ways. They talk about different things. So they have wireless power transfer for your cars. That's kind of neat. They could perhaps do that bidirectionally. A lot of stuff might not be around yet, but you're here to learn about the future and not just the past. Electric vehicle supply equipment, EVSE, that's also known as an EV charger. Or if it's bidirectional, it would be a bidirectional EVSE. We have different types of chargers. Definitions are just pretty much straightforward. If you want to look at all the definitions, you can go look at it in the National Electrical Code yourself. Different EV voltages, cable systems, different ways of installing things. And so one of the things that's going to be kind of relevant for us is if we are feeding our electric car to the grid, our energy storage system to the grid, and a PV system to the grid, that's a lot of things feeding the grid. So that will bring us to Article 705, Interconnected Power Production Sources. And there's something called 705.13, and that's power control systems. And we're going to probably want to use a power control system if we're feeding so many things to the grid. So beyond 625, we have electric trucks, welders, signal processing, information technology, data centers, pipe organs. Let's kind of go fast here because we're not going to get into pipe organs, swimming pools, bodies of water, integrated electrical systems. There's Article 690, that's for photovoltaic systems. And most of the energy storage information that we're going through in the National Electrical Code, like Article 706, like Article 710, is these articles came out of 690. So 690, I would say, is relevant to what we're doing. Article 691 is for larger solar systems. And so that would be systems over 5,000 kilowatts, which is 5 megawatts. That's Article 691 for those big, large systems. It's fuel cell systems. So remember, flow batteries, when we looked at that, it sent us over to 692, which is fuel cells. And so typically we're thinking of fuel cells like hydrogen fuel cells. However, there are different types of fuel cells besides hydrogen. And so you can say that fuel cells are energy storage. But if you're using natural gas to make these fuel cells work, it's not really energy storage any more than a natural gas tank is energy storage, like the Bloom box. And so that's something that you send natural gas into, and then it turns it into hydrogen, and then it makes it work like a fuel cell. And most of the places where you fill up your hydrogen car are actually using hydrogen that is made from natural gas, because it is cheaper to make hydrogen from natural gas than it is to make it from renewable energy, where you stick a positive and a negative wire into water, and off the negative comes hydrogen, off the positive comes oxygen, splitting water, water cracker, cracking things, splitting them apart, just like a nut cracker for water. There's just some different requirements for fuel cells. It tells us if you're using them in a DC microgrid, an AC microgrid. One more thing I wanted to say about that, though, too, is like it's cheaper to make hydrogen with natural gas, but as the price of renewable energy goes down, that's going to change. The price of natural gas will go up as it gets all fracked up. We use it all up. Gets harder to find. That will happen someday. The question is, will it happen in the next 10 years or the next 100 years? But the price of renewable energy, such as solar and wind, is going down and down and down. And also there's times where somebody might curtail a renewable energy system. So that means there's just too much power on the grid, and maybe all the lithium batteries are full, all the flywheels are spinning. And so instead of just curtailing that power, that just means turning off the PV system to a certain degree, we can use that energy to make hydrogen rather than throwing it away or putting it into a Bitcoin miner. So we can use that energy to make hydrogen. And also there's a way of converting hydrogen into liquid fuel, maybe for your airplane, or maybe just for long-term storage. And so they talk about long-term storage for that. So anyway, that was a little bit about hydrogen and why we will be seeing it more and more, and then how it's cheaper to make hydrogen from natural gas. But sometimes when we just have all this extra solar and wind energy lying around, we might as well turn it into hydrogen. And that works good for long-term storage. So circuit requirement, it's pretty much the same as the circuit requirements that we had for Article 706 energy storage systems and 690 if you like to use that. Disconnecting means that's going to be very similar. Wiring methods, that's going to be very similar to energy storage systems. And then when we have stored energy, we're going to talk about our electrical energy storage devices on a particular sign. And so let's move on. We have completed our little discussion on 692 fuel cells. Then there's wind. A lot of times, though, wind is utility scale because a small wind turbine does not pay back very well. And so it's just better to go with solar when it's a smaller system. But the wind that gets really cheap is the big utility scale stuff. And if you are doing something that's huge, like a utility, then typically you might not be following the National Electrical Code. You will be following the NESC. That's the National Electrical Safety Code. So utility scale, once again, uses the NESC, not the NEC. So Article 695, fire pumps. And we're not going to really cover this that much, but I just thought it was interesting to note that if you have a building burning down, you're not as concerned about your overcurrent protection device opening up the circuit because it might be a case where the building is already on fire. So you could set your overcurrent protection device for a lot higher than you would in another situation. So 600% of full load current in that one case. And it's not too uncommon when there are fires that people do burn up wires. But hey, there's already a fire. So are you going to be preventing a fire or are you going to be putting a fire out? And that brings us to the end of Chapter 6, Special Equipment. Now we are on to Chapter 7, Special Conditions. This includes energy storage systems, Article 706. Let's just kind of take a peek at some of these things. We have emergency systems, standby systems that are legally required, optional standby systems. And so just one thing that's interesting about optional standby systems is if we were going to invoke Article 702 instead of Article 706, because you got to admit there's crossover here, standby systems, energy storage systems. So if you have an automatic transfer switch, otherwise known as an ATS, the ATS has to be able to handle the full load in accordance with Article 220, which is branch circuit feeder and service load calculations. So you have to do load calculations and be able to handle the full load with this automatic transfer switch. So what we're not going to do is we're not going to call it an automatic transfer switch. We can pretty much have the same piece of equipment and then go to Article 706, energy storage systems, and we will call that a microgrid interconnect device. So when the grid goes down, you transfer over to your battery backup, your energy storage system, and if it's a microgrid interconnect device, MID, then you don't have to do Article 220 load calculations, which could really get in your way and require you to have a huge energy storage system inverter, lots of power coming from that energy storage system to be able to handle all these loads. If we go over to Article 710, we only have to back up the largest load instead of all the loads. So let's try not to call things an automatic transfer switch when we could call it a microgrid interconnect device. And then we will be using Article 706. Okay, what I'm going to do right now too is I'm going to breeze through all of different articles. So we have 705, interconnected power production sources, 706, energy storage systems, critical power, 708, 710, standalone systems. It used to be Article 690.10. We would call that Section 690.10 because it's in Article 690. And it's just all these special little things about having off-grid backup systems. Sometimes you might have a house that's 120/240 split phase, but your backed up circuits are just going to be 120 volts. So you can use 120/240 subpanels for your circuits, and you just bond line 1 to line 2, but you need to have a sticker there if you do that says 120 volt supply, do not connect multi-wire branch circuits. And what that means for you advanced people is that a neutral on a 120/240 system only carries unbalanced currents. So the currents cancel each other out. That's kind of the beauty of 120/240. 10 amps line 1 to neutral, 10 amps line 2 to neutral. You got 0 amps on the neutral. But if line 1 and line 2 were bonded to each other, and so you would just pretty much have line 1 to neutral and line 1 to neutral, then on your neutral, you would have 20 amps with those two 10 amp loads. And if you used a multi-wire branch circuit, so that's like a conductor, some people would call it Romex, You can't use the multi-wire branch circuit type where you have line 1, line 2, and neutral if you're just going to use 120 volt supply. So you don't want to overload those neutrals. That's what that's all about. I know that's kind of advanced. If you are doing a standalone system, which would include grid tie battery backup, because when you're operating in backup mode, that is standalone, and so you would have to follow this short article. You can also go to my podcast at solarshawn.com, and I read this article so you don't have to read it. Okay, that's it for 710. Now we're going to go to 712, direct current microgrids, and alternating current microgrids is covered in Article 705, and there's a rumor that 712 might get merged into 705, because it's kind of weird that alternating current and direct current pretty much follow the same rules most of the time. And one of the things about microgrids is you're just connecting a bunch of different things together on the DC side. So it's sort of like an analogy to DC coupled systems. And then, of course, if you are connecting a DC microgrid to a grid, then it's going to have an inverter there that's converting DC to AC. Not a very long article, and it follows a lot of the same rules that the rest of the National Electrical Code follows. And then there's Article 720, circuits less than 50 volts, 725. Both of these, 720 and 725, are not commonly used with energy storage systems, instrumentation cable, fire-resistant cable, energy management systems. So energy management systems is part of the future of energy storage systems and renewable energy systems. And let's just read the definition of energy management systems. It's a system consisting of any of the following: a monitor, communications equipment, controller, timer, other devices that monitor and or control an electrical load or a power production storage source. So we're starting to see more smart equipment, such as smart load panels, and these energy management systems are also probably going to be working with called a power control system, a PCS, which is new in the 2020 National Electrical Code. In fact, there might not even be a way to tell the difference of an energy management system and a power control system. So we're going to be able to control the loads. We're going to be able to turn certain loads off. So say your power goes out, you might turn off the air conditioner because it's such a big load, it'll make your battery dead in no time. And then there's certain loads that you can't turn off with energy management system, such as an elevator. Who wants to get stuck there? Ventilation for hazardous gases, emergency lighting, healthcare systems that are essential. Yeah, you don't want them to turn off your ventilator. It's not a very long article, and it's energy management systems. We've got fire alarm systems. We've got optical fire cables. And hey, while we're at it, let's just go to the end of the National Electrical Code. Chapter 8, communication systems. And so Chapter 8 is not part of the normal wiring systems. But as we're getting smarter, we're having more and more communication circuits. And so you might be interested in Chapter 8. These things are going to be not so dangerous. You know, you're talking about your Cat 5 cable, stuff like that, usually. Then the Chapter 9 tables. And I'm just going to mention a few of the tables that we use. There's Table 1, Table 4, and Table 5. And you would use these tables. They're pretty self-explanatory on figuring out how many conductors physically fit in a conduit. And also to get the same information, it's easier to use Annex C, and it will get you all the same information in Annex C if all your conductors are of the same size. But if you have different size conductors, you're just pretty much calculating how many circles fit in a circle and give you proper airflow. And those are Tables 1, Table 4, and Table 5. And I go over this in my book, PV and the NEC. And then one of my favorite tables, Chapter 9, Table 8, Conductor Properties. And we use these tables to do calculations for voltage drop. So we could figure out the resistance of a wire and then figure out how much voltage drop we're going to have. And once again, I go over this in detail and pretty much everything that we're talking about here in detail in my book, PV and the NEC, which next time I'm going to call it PV Energy Storage in the NEC because it covers energy storage. So I hope you learned something, and you can listen to this podcast over and over again until it is in your brain solid. And thanks for listening to Shawn White's Solar and Energy Storage Podcast. To find out more about everything solar and storage, go to solarsean.com.